Assalamualaikum and very good afternoon. I will introduce our teammate, which is firstly Adib Sirhan, and secondly me, Adib Shazwi, and lastly Iman Shahmi. So next, I will continue with introduction to our mini project, which is many schools struggle to provide hands-on chemistry experiment due to space, time, and resource limitation, affecting student understanding and interest. To student this, mixed reality and virtual reality application is purpose, which is we develop this to VR and MR, allowing students to conduct virtual experiment using hand gesture and immersive learning experience. This solution will enable school in Malaysia homeschooling parents to incorporate practical chemistry education without needing physical labs, bridging the gap between theory and practice. So secondly, 2.0 problem statement. The traditional method of teaching chemistry relies on physical laboratory session, where students conduct hands-on experiment. However, many schools that offer chemistry face significant limitations that hinder effective practical learning. So firstly, we have limited lab space. So secondly, the problem statement is time constraint. So thirdly, insufficient materials, and lastly, safety and cost issue. So next, I will continue with objection for 3.0. So objection is goal, and we want to enhance hands-on learning with visual experiment, provide flexible access, reduce resource dependence, improve comprehension with 3D visual, and ensure a safe environment for hazardous experiment. So how to achieve our goal? Firstly, we need to simulate lab, create an immersive real lab experience. Secondly, hands interaction, which is enable natural intuitive experimentation. And thirdly, unlimited practice, which is allows repetition without a materials constraint. And lastly, anytime access, which is integrates seamlessly into school curriculum. Okay, so continue with up next.
Our project will only cover a secondary school student in Malaysia that is learning chemistry. This will cover only chemistry syllabus in secondary school in Malaysia. We will only use the already developed hardware for VR and AR project. We will not cover university level chemistry. This project will not be a full-on module of chemistry, and we will not develop any new VR or MR physical hardware. For this project, we use two fact-finding method, that is interview and questionnaire. For interview, we conduct interview with one of the teacher at SMK Puchong. From our interview, we found out that most students, when they do experiment at that school, we oftentimes break the material in there, like a thermometer or a jar, and also they sometimes will need to repeat the experiment because of misstep or miscalculation. From our questionnaire, we find a fact that can support this claim. I will read the fact is here. The survey results support this, as 56% of students find chemistry is difficult because the main reason include the struggling with theory, troubling visualization reaction, and memorization issue. From our survey, we also find out that when we ask them how do they study for this kind of experiment, 100% of them say they use textbook, 78% say they watch a video on YouTube, and 56% use interactive app, and only 33% get hand-on practical activity. That means only 33% get to do the experiment and get to do it as a practice. And as to the preference or the way they would like to study, 78% prefer a visual learning, a video or diagram, 22% prefer a practical work, and 0% prefer audio-only method.
Assalamualaikum and hi, my name is Iman Syahmi bin Syahriman and my metric number is F1006. Now, I'll be talking about our project usability and functional decomposition diagram. Let me begin by discussing the hardware and software costs for this project. So, for hardware, we use 3 units of laptops, 1 unit of VR headsets, a smartphone and a VR box. The total estimated hardware cost is 13,050 ringgit. For software, we utilize free tools such as Unity, Blender, Molecule AR Web, Avogadro, and Canva. This made the software cost is 0 ringgit. By leveraging free software tools alongside affordable hardware options, we ensure the project remains cost effective without affecting on the quality. Next, I will be explain about the project scheduling using the Gantt chart. The timeline begins with identifying educational goals and user needs in weeks 1 and 2. In weeks 3 to 4, we analyze student challenges, brainstorm the ideas, and create the storyboards. From weeks 4 to 8, we design the AR interaction models and animations. The system construction and prototype development occur from weeks 7 to 9. In weeks 10 to 12, we integrate the AR features into the system. Finally, user surveys were conducted in week 12. Followed by the feedback analysis in week 13. Now, let's move on to the functional decomposition diagram of our system. The system is divided into 4 key components. The first is user interaction, which allows students to log in, manage their profiles, select experiments, and navigate using the VR controls. The second component is virtual experiment execution, where students interact with the visual lab equipment to conduct experiments. This includes simulating chemical reactions while following the safety guidelines. The third component is data collection and analysis, which enables students to visualize the experiment's results, receive performance assessments, and access feedback reports. Finally, the fourth component is system management, which tracks user progress and ensures the system is regularly updated and maintained. So, for the conclusion, our chemistry VR simulation system provides an innovative solution for enhancing chemistry education by making experiments more accessible and engaging. By integrating virtual reality technology into learning processes, we aim to overcome traditional lab limitation while ensuring students have a safe and interactive experience. That's all for our mini project presentation. I hope you now have a better understanding of our chemistry VR simulation system and its potential to enhance learning experience. Thank you so much for your time and attention. Bye.